Assalamualaikum and greetings. My name is Muhamarrazif and my team will be presenting a project for International Teaching Enhancement and Learning Innovation Carnival 2025 by Universiti Malaysia Kelantan. Before going through our presentation today, I want to show you all my team members, which can be seen here. All of them will be presenting soon, so look forward to it. Without further ado, let us go through the presentation. The titles of our project is Innovation in Geological Mapping. Geological mapping is a very important skill for geologists, so undergraduate students will need to learn it. So what sets apart our projects is the emphasis on student-led real-world geological explorations. We, the students, go through 3 different outcrops within the UNK campus. Unlike traditional classroom models, students were introduced to hands-on techniques such as GPS coordinations and conducting outcrops, measurements, meteorological units, and more. The final details will be presented by my teammates. So, without further ado, let's see their presentation.
My name is SUFIAN. I will talk about a project description. Our study area is located inside Universiti Malaysia Kelantan in UMK actually. This area is belong to the central of Peninsula Malaysia. So, on our fieldwork was carried on 27th of April 2025. I will put some fieldworks detail about the coordinate and the time. There are 3 outcrop for A, B and C. For the outcrop A, we take this nearby the FSB, Fakulti Sains Bumi, and for the side B and C, we'll take along the side of the road to the second agro park. For the side A, the outcrop is about 1.1 meter high and 0.8 meter weight. For the side B is around 3.3 meter high and 2 meter weight. And the last side is a side C. The outcrop was around 2.8 meter high and 4.8 meter weight. Okay. For the side A, we mostly observe the soil have become a tiny fracture. If we put some pressure on the rock, it will be broke and become a powder. On the side B and C, the rock color is white to the light and dark grey and brown. The texture is a fine to medium grains. We also can see the wisty mineral. On the grain size, the sample B is a bit soft and more easier to break. On side C, the sample a bit hard like a cement. For the weathering, we can divide it by 2. First, physical and second is chemical. For the physical, based on our observations, we can say that it was by a human factor because the side B and C was near by a side of the road because before this it was a hill, so the hill has been cut to make a road. We also noticed a chemical weathering. The iron in the rock will react with the oxygen and water when they are open and exposed to the air, and will produce a color to the orange when we observe the outcrop at the top of the soil. So that's all for me.
Alright, for the last one, it's prepare for future geoscience theory. Finally, this project prepared us for more advanced study and professional work in geoscience. The field, the field experience we gain here becomes a strong foundation for our future career as geologists. That's all for me. Thank you. The third one is improve observation and spatial analysis. We also aim to sharpen our observation skill, like sketching outcrop, recording coordinate using GPS, and analyzing the spatial relationship of lithology and structure. This develop our ability to think critically about the geology we see. And then for the next one is strengthen teamwork and documentation. Another important objective is teamwork and scientific documentation. We work in group to systematic field notes and practice clear scientific communication. These skills are essential in both research and industry setting. Okay, my name is KHAIRUL IBRAHIM. Now I'm going to explain about objective. The first one is develop geological mapping skill. The first objective is to train us in basic geological mapping technique such as identifying rock type, measuring outcrop, structure, and recognizing geological boundaries. These are the foundation skill for every geologist. And then for the second one is to apply theory to real field. Instead of just learning in the classroom, this project allows us to directly apply the theoretical knowledge in the field. Working on the outcrops at UMKJLI help us understand how classroom concepts are used in real situations.
Hi, so from my part, I would like to talk about the novelty and originality of this project. So, the project shifts away from traditional classroom-based geology lesson and instead emphasize student-led hands-on field exploration at UMKJLI campus outcrops. So, it combines basic geological mapping, which is traversing, sketching, and lithological identification, with the idea of introducing modern digital tools like GIS-enabled apps, 3D programmetry, and mineral ID apps. It also proposed gamification and collaborative digital field journal, which are not commonly applied in standard geological field courses. For the originality, the approach provides an integrated experiential learning model that not only teach mapping but also strengthens students' spatial reasoning, teamwork, and interpretation skill. It situates the study in Malaysia granitic terrains, which is Kelantan Central Belt, making it contextually unique for local geology while aligning with global geoscience education practice. So, the originality lies in blending traditional geological field technique with future-forward innovation like digital mapping, 3D modeling, and cross-disciplinary integration, which is soil or weathering profiles and hydrology. So, in short, the originality is in combining classical geological mapping with digital innovation and interactive learning method tailored to the Malaysian granitic setting. So that's all from me. Thank you.
Now, I will explain the usability and impact of our geological mapping project at University Malaysia Kelantan Jeli Campus. First, let us consider the usability. This project was more than an academic test. It was a practical training that mirror real application in geology. We learn to use tools such as GPS logging, outcrop scratching, and lithological description, which are the same method applied by professionals in industry and research. From our fieldwork, we identify granite and weathered granite as the dominant rock. This knowledge is not only important academically, but also highly relevant in practice. For example, understanding rock type and degree of weathering is critical in construction planning, slope stability, and land use management. Looking ahead, the method we apply can also be enhanced by mobile GIS and 3D photogrammetry, making geological mapping more accurate and efficient in the future. Now, on the same impact, at the personal level, this project helped us develop essential skills such as spatial awareness, teamwork, observation, and critical thinking. This skill can transformable and prepare us for professional career in geology, geoscience, and related field. At the academic level, our work contribute to build a geological knowledge base for UMKG, which can serve us as a reference for future student and researcher. The project also demonstrates the potential of innovation through digital and journal and modern mapping technique, ensuring that fieldwork remain relevant, accurate, and accessible in the digital era.
Now that we know the details about this project, let us see the commercialization potential of it. First and foremost, of course, educational products and training service, such as fieldwork training packages, e-learning modules, and digital mapping kits. Secondly, it can also be applied to digital tools and software such as mobile mapping app or 3D outcrop database. Then, it can also be used in edu-tourism or public engagement, such as geoscience field camps or interactive exhibit. And finally, publication and licensing, such as geologic field guidebooks and license mapping contents. Now, I think how about we look back at some points and make our conclusion. Now, looking back at our projects, we can conclude that it helps students strengthen their practical skills in geological mappings through activities such as lithological identification, GPS logging, sketching, and outcrop observation. We can also identify granite and moderately weathered granite as dominant lithologies around your MKJLE campus through the testing of our project. This project also promotes active student-led learning that bridge theory and real-world geology through, and like I said before, hands-on practical skills. This also showcases potential for innovation through digital tools such as GIS, photogrammetry, and other apps. And finally, it provides a strong foundation for future geoscientists and opportunities for commercialization in education, industry, and outreach. Now, before finishing up this presentation, I want to express our gratitude to Universiti Malaysia Kelantan UMK Faculty of Earth Science for providing facilities, academic guidance, and field access. Our project supervisors, Dr. ELVAENE James and Dr. HAFZAN Eva, for their continuous support, knowledge sharing, and encouragement through the study. Fellow students, and also of course, my team members for the commitment to ensure the success of these projects. And I think that's all for this presentation. And I thanks all of you for listening. Thank you.